Okay, as I promised you, I'm doing for you some exercises in order to help you studying for the exam of the next week, okay? One of the exercises we didn't do was the 24. 24, as you can see, said to us the gravity of the moon, and the question is time taken for a free fall of a sphere, okay? You know that the Apollo 15 did this with a sphere because a sphere or a piece of iron falls the same on the moon because we don't have atmosphere, okay? Then the height is 1.5, this is a free fall, this is the gravity. Then if you remember, the formula of the free fall is height 1 divided 2 gt squared. What does it mean? That if we know that the height is 1.5, we write 1 divided 2, 1.66, that is the gravity of the moon, times the time taken, then we can calculate this way the time. Time is 2 times 1.5 is 3 divided 1.67, the square of this, no? Then as appears on your photocopies, the solution of this is 1.34 seconds. Just that, okay? The formula of the free fall. The activity says too that you do the same in the Earth in order to compare. If we do the same in the Earth, it's just 1.5, 1 divided 2, 9.8, because it's the gravity of the planet Earth. Then this time we isolate time, and it's almost the same. The only difference is the denominator, that is the gravity of the Earth. That's to say that in the photocopies appears that it's 0.55 seconds. Then in free fall, this is the formula of the free fall, and that's all. Imagine you're asked for the velocity. If you are asked for the velocity, velocity is gravity times time. Then, for example, on the Earth is 9.8 times 0.55. This is around 5 meters per second. This is the way to calculate the velocity. These are the classic questions we do in a free fall. Height or time. If we have time, we can calculate height. If we have height, we can calculate time and velocity. Free fall, remember, without initial velocity. What about the vertical launch? The vertical launch, this is different because we have velocity. Then with this velocity, we can know what is the maximum height rises by a rock, for example. Then this velocity is 20, and we want the height. This time, height. The height is initial velocity times time minus gt squared divided 2. The question is the time. Then, how can we calculate the time? In all the vertical launches, time is always the same because we use the formula of the velocity. The formula of the velocity says that the velocity up, that is 0, is the velocity down 20 minus gravity times time. That's to say that the time is always initial velocity divides gravity, 2.04. This is the time to reach the top of the trajectory. Then, if we want height, maximum height reached by this rock, is just to place in the formula the different magnitudes. 20 is the velocity, 2.04 is the time, minus 9.8 is gravity, 2.04 squared divided 2. The height this time is around, I think it's 20 meters. 20 meters. It's around 20 meters, okay? Depends on this is 20.4, 20.3 meters. This is height, okay? Then remember, this is the difference between the vertical launch and the free fall. Free fall, we have this formula. In vertical launch, we have initial velocity. Then we always calculate time from the formula of the velocity. Knowing the initial velocity, in the top, final velocity is 0, then time is velocity divided gravity. So it's the same, 2 seconds. And that's all. Imagine you are asked, what is the total time to return to the ground? Then we say total time is the double of this. Remember, as this motion is symmetric, the double of this time is the time taken by the rock to return to the ground. That's to say 4.08 seconds. And imagine you are asked, what is the velocity when the rock touches the ground? The same velocity, we throw it up, 20 meters per second. Okay? That's all. Imagine you are asked, for example, in other point of the trajectory, what's the velocity? Then we calculate the time to this point, and with this time we can calculate the velocity. Okay, but basically, this is the calculation in these problems, free fall or vertical lunge. What about the circular motion? In circular motion, if you remember I told you, here the point is the angular speed. Then the angular speed or angular velocity is the point here. That's to say, we need it. Then the usual is that in the problems appears the angular speed in revolutions per minute. Then if you have the angular speed, in revolutions per minute, what we have to do is transform revolutions per minute. Imagine we have 1,000 revolutions per minute into radians per second. How do we do this? Remember, this is 2p radians per spin and per revolution and 60 seconds per minute. Then this way we can transform revolutions per minute into radians per second all the time. Imagine that the data is the period. It's classic too. For example, we have a carousel and the time for one revolution is 8 seconds. Then if you have the period, then to calculate omega, you use the formula that give us the ratio between omega and period. And this is the formula, 2p divided period. This formula is the definition really, because omega, angular velocity, is space divided time. When the space is 1 revolution, 2p radians, the time is called period. Then with this we can get 2p divided 8, for example. This time we have the velocity in radius per second. And with the angular velocity we can calculate all the other questions. Usually remember that in these exercises of circular motion we calculate angular speed, period, or frequency. If you remember, the frequency is just 1 divided period. And the other calculations we do are related to the radius. You remember they are linear velocity and centripetal acceleration. Remember, linear velocity is just angular speed or angular velocity times radius. What does it mean? That you need the radius. If we don't have the radius, we can calculate the linear velocity. If we have the radius, we can't. And what about the centripetal acceleration? It's just the same. It's velocity squared divided radius. Then, if I want to ask to you the velocity or the centripetal acceleration, I will provide you the radius. The other magnitudes, that's to say period or angular speed, they doesn't depend on the radius. They don't depend on the radius. Then we can calculate them just with the revolutions, because it is omega, exactly. Or if we have the period, for example, we say omega is 2p divided period. Or imagine that the data of the problem is the frequency. I say to you, a turbine is spinning with a frequency of 10 Hz. If you have the frequency, you start with the formula of angular velocity with frequency. If you see this formula, angular velocity is 2p divided period. As 1 divided period is frequency, if we change here 1 divided period by frequency, we get this other formula, 2p times frequency. Then in this problem, in the problem where we have as data the frequency, we start this way. Then with this way we can calculate omega, we can calculate period, it's just 1 divided 10, and with the radius, velocity or centripetal acceleration. Okay? Remember in the exam, one exercise related to this, uniform linear motion, and one exercise related to the accelerations in the gravitational field of the planet Earth. It could be free fall or vertical lunge. That's all. I hope this video helps to you. Bye-bye.